Okay, welcome everyone. This is my first meetup in Rotterdam, and this is something I really want to keep in this device here. So let's see if you're all still awake. That's always a good moment to kind of re-energize you. So how so far do you like Kotlin at the meetup in Rotterdam? Cool, nice. So the energy is still there. Short introduction. There was already one. For the ones who don't know me, I'm Urs Peter. I'm a senior software engineer. I still code a lot, and I'll try to keep doing that. Indeed, the forum will maybe change in the future, but try to do as much as possible. I'm also a passionate trainer, foremost giving trainings about Kotlin, and also that is going to change because now it's probably not about languages anymore, but more how you apply this in AI assistant form. So there you see a transition going on. I also do still architectural trainings, event-driven architectures. That's something that is still kind of intact. So architecture is something you probably still need to know to build, especially on enterprise scale. AI cannot do that much on that level. Can support you, but their knowledge is still required. And recently I launched this training here, building AI-powered applications for the GVM platform. So if you want to go into agentic and know all about vector databases, agents, agent graphs, MCP servers, actually the whole ecosystem that is now being created, and you want to kind of dive into that, there is a great course for that. Well, I'm a certified trainer, you probably see me at conferences. I'm the co-organizer of Kotlin Dev Day. You already seen it on his shirt. So we're organizing once a year this conference. Last year was in November. I also will talk at Kotlin Conf. I also do a course there about a deep dive about Spring Boot with coroutines. So kind of to get the most performance out of it, which I think is still relevant also with AI assistant code, because you need to evaluate whether code performs well or not. That's something AI is particularly bad in, and when you don't know anything about that, that kind of can be a big hindrance. And for the ones who join Kotlin Conf, is anybody going? Nobody. Come on. One. You get 5% reduction. So this is the code I'm allowed to show you. Kuga Kotlin Conf 5. That's the ticket to a much cheaper access to Kotlin Conf. Okay. I'm actually quite curious about you, and especially your knowledge about building agents. So who of you has built an agent? 1, 2. Okay. Who has built an agent that made it to production? I could have expected that. And that's kind of interesting, right? Because I believe that in a few years from now, if these models get really mature, maybe we also should kind of transition into building more autonomous systems, leveraging these models, which is really a different way of creating software than what we do now. So I think it pays off to get used to this new way of programming and thinking. In this presentation, you will get the first encounter of what it takes to build these systems, and then, of course, how you make them more mature. Okay. Well, these are some interesting snippets out of reports of kind of relevant companies that do those reports, like Gartner. And they say 40% of agentic AI will be cancelled by the end of 2007. That's quite a lot. Another one, MIT report, also a important institution, 95% of vendor-driven AI pilots or companies are failing. These are significant numbers, right? Well, if you look at the reality today, there was this really awesome trial of, guess who, Anthropic itself, right? The best model builder in the world did this project. So this is not just a no company trying out stuff. These are the creme de la creme of the world doing their best building something like this. There's a vending machine benchmark. So if we give a vending machine to an AI, how does it operate it? It's kind of operating a small business in the form of a vending machine. That's the way you have to look at it. And well, if you see that what happened, it gave away free PlayStations, it ordered a live fish. It also got free drinks for everyone because the user who interacted with this bot made it clear that this is a kind of communist company where just everybody gets free beer, and everybody in the end got free beer. Even so, a lot of guardrails and so on were in place. So even the best companies in the world struggle to make something reliable. Which doesn't mean, of course, that we shouldn't try. Okay, well, if you play around with agents and create something like an agentic application, you quite quickly can get this feeling, right? You get something that does a lot of stuff. You can talk to it, it answers back, it can integrate some data you provided. It's very, very easily created. Up to the point when you get in production, then things can get dire. I don't know if you know the story of the sorcerer, where this kind of apprentice magician got the head of the master and tried out stuff, and then it went direly wrong, right? This is in the end where things were so wrong that in the end it was resolved by the sorcerer, because the sorcerer came along. So there was this kind of authority that came along and fixed it all. However, in the AI case, this is not possible, right? Then you are the big sorcerer to make sure that the mess you created needs to be cleaned up. You cannot call upon a higher power. So, this brings actually this question, right? So how do we tame traditional applications? And I'm very confident you all know how we do this, basically with testing. This is a very integral part of software development, is testing. And we have a lot of tests, right? It's unit tests, integration tests, pyramid-shaped or diamond-shaped nowadays, that you focus more on integration tests than unit tests. Then you have E2E, chain tests, performance tests, E2E tests, UI tests, and maybe even disaster recovery tests. And in my current client, we do all this. And we build about 3 times more test code than we build production code. And by doing so, we can really deliver new features without having actually to look at tickets minimally. So maybe every sprint you have a small ticket of a tremendous amount of park we maintain. Because these tests gives the confidence that everything works as supposed. And we are also in a critical environment. And of course, when all these tests are green, then we ship it. That's, I guess, not very surprising to most of you, I hope at least. Right? Okay. And of course, once in production, we have a bit of monitoring, that we see, okay, do we get stack traces, what is the latency, things like that, right? Maybe Grafana or Datadog or whatever these tools are, give us some hints whether our production system is healthy. And in very rare cases, maybe after deployment, you might get alarmed, but that's not something you have on a daily basis, hopefully. Okay, so if you had the kind of notion that if it compiles, ship it, in the current world, everybody would say, you are really a no-no. This is just insane, right? They hang your poster everywhere and tell you, what are you doing? You are just you're not allowed actually to execute this craft. However, when we build agents, it's really going like this, right? So you code something and we check whether this router is doing it, and if it does, then you hit production, because, well, what could possibly go wrong? So it's kind of interesting that working with AI systems, we are really back in time, in the 50s, where, well, this kind of ideas were prevailing. Real devs test in production, right? My code is just coming from above, so what could be wrong with that? So, and that's interesting. So why all of a sudden we let all these good habits go, and because it's a bit of new technology, believe all these things that could happen in the other area won't happen anymore. Well, the reason for that is that the systems we build now are deterministic. That's it. So, which actually results in either tests being green or not. That's a binary world. And if tests fail, well, we don't ship. And we fix it. And when everything is fixed, we ship it. And maybe in production, we still monitor, things still can go wrong, but these are more or less exceptions. Once it passes all the tests, we have kind of a guarantee that everything works the way it's supposed to work. However, agentic systems are not deterministic, they're probabilistic. And that's something, especially we as kind of front-end, back-end developers, have to embrace. Data people, right, data scientists, are much more used to work with these probabilistic system types, to work with data, to see how certain data reacts with their models. That's kind of ingrained in their workflow. In our workflow, it's not. That's something we still have to kind of learn and absorb. So this is what we want to achieve, right? That they behave well most of the time. So what makes agentic systems probabilistic? What is that exactly? And it's actually a lot of moving parts we have in the whole mix. So when we look at the traditional application, prompt, let's say a prompt application, then first of all you will send some system prompts, you will send some user prompts, you will send some context to an LLM, which can already have a lot of variations. The LLM itself is of course also a source of probabilistic behavior. An LLM is never deterministic. It will always generate a new type of response. You can adjust that, right? Maybe not P, all these kind of parameters, but nevertheless, hallucinations, sooner or later it will happen. It's a question of when, not that they won't happen at all. We often also add some context to our conversation with an LLM, and for this we often we also rely on certain type of databases or even RAG databases. RAG databases, they also use models. These also neural networks that depending on the model it can behave quite differently. So the embedding models we use has a big impact on which data we retrieve. And that's also not deterministic. Then we have tool calls. The question is, are tools called or not? Right? So when an LLM instructs the caller to execute a certain tool and then view the response back, this is actually how you can execute behavior on your machine or on your server. With an LLM, LLM cannot do that, so it just instructs the caller to execute stuff. This could be really everything, file system lookup, API, DB. When you develop locally, then it will be a file system that most of the time will be accessed using tools. That's basically how an AI agent works also for coding. It also works for business agents. So, and often you have a large variety of tools you will provide. Which tool is picked? Is the right tool picked for the right moment? Also there, a lot of variations. Then you have MCP servers, which is actually the same like a tool, but then more or less made accessible for not only application, but for everyone. And also these tools do more or less the same. More or less they are often connected to a certain SaaS offering, like Slack, issue tracker, things like that. That's where MCP thrive, but of course MCP could be anything too. And your agent could also talk to other agents using A2A. That's a protocol to have agent-to-agent interaction. And of course also these agents can behave in a non-deterministic way. So in the whole mix, if you create such an application, you very quickly have all of these spots filled in. There is a lot of things you just cannot control. You don't know how this whole thing will behave. This is a nice quote of George E.P. Box, that's a statistician, a very famous one, which I think very important to grasp. All these models are wrong. What LLMs do still, they predict next tokens. They also kind of, scientists say, with this approach, we probably never get kind of AGI, the general artificial intelligence. We will see. There are different models in the making. Eventually, they definitely will get better, but they still can be wrong. Nevertheless, it can be useful. And our task is to kind of live with the fact that they're wrong and make them as useful as possible. That's what we try to achieve. So this is the quest. And to accomplish that, we need to embrace this, Eval-Driven Development. That's the term for it, the official term, which is really a big shift from this deterministic world where we have this green and red to basically probabilistic systems with a confidence score. Because you have so many options, you cannot say it's green or not, you just can say it behaves pretty good. So the focus is on quality rather than correctness. Deterministics, they have to be fully correct. Here we aim for quality. And quality, of course, is much more diffuse than correctness, which is binary. So EDD aims actually for these three categories. First, we want to control the accuracy of our system. That's what we try to achieve. And by doing so, we need to define quality criteria. When do we think a certain interaction was successful or not? That's very fuzzy, right? That's often also semantic. A lot of semantics come in here. Which also means that we need to know the base expectation of our system, which is something that is not really clear compared to deterministic systems. When we build something, what we just seen, it's kind of evident here. You have dossiers, then you can look into details, you can download stuff. That's kind of evident operations. When you something like a chatbot, what is your base expectation of this chatbot? There's so many ways the user can interact with it that this is not really evident what this is going to be, so you need to be as specific as possible with that. And then, of course, you want to build a regression similar to our old testing world, and from there on, well, navigate, which will also help you then identify areas you could improve. So accuracy, controlling that is crucial. And the big companies do exactly that, right? They do develop Eval-Driven Development. The open APIs, the open AIs, the Anthropics and so on, they use this methodology to also improve their own bots. What you also want in a certain stage is control costs. That's crucial too. And eventually also latency. If you have interactions that take a lot of tool calls, it can take quite a while. And nowadays we're used to that. We get a spinner, right? And we think, okay, thinking. You see the term thinking, and you're fine with it. We actually come from a world where it couldn't be fast enough, so very snippy, like Google search nowadays is back. And now we get to a world again where we accept that we simply can say, okay, let's wait a bit because it's thinking. So there, user behavior is also an important aspect. Okay, so let's see if we are worthy to carry that sorcerer's hat, to do real magic that doesn't get out of hands. Okay, so if you look at from your perspective as a developer, EDD, Eval-Driven Development, is something like TDD, test-driven development, but then really on steroids, heavily focusing on data. That's basically how you can look at it. Which brings us actually to the beginning, where you need to define very clearly what is the goal of your application. As said, the user just has a prompt to enter some text, and what does your application actually has to do? That's not a straightforward thing like a deterministic application where all the functions are very clearly defined because it's inherently in there. This is just an interface that can go in various directions. So having the goal clear is very important. Also, who will use it and what such user will expect is relevant. And then also scenarios, right? So what kind of scenarios are you going to support? This is something you have to define more clearly than with traditional applications. Once you have this in place, then you can start building this, a minimum viable evaluation. And for this, we first need to generate test data. Also here you will heavily rely on LLMs. You won't invent all the test data yourself. You will have test data generated by LLMs. So what I've created here is an application. It's quite a simple one. So here this chat method, Spring AI. Who has worked with Spring AI before? Tried stuff out? Not many of you? Okay, a little. So it looks, it's actually quite simple. It's like a normal Spring control, right? But then you have the core ingredient is chat client, which can talk to different kinds of LLMs. Just configure an LLM and a token, and then it figures out itself how to talk to that LLM. That's basically how it works. And then you have often a system prompt, which is guidance to the whole conversation. You have the message the user enters. You provide a variety of tools. And also some context, because you also want to have some history. Right? When the user interacts with the system, then you also want to know what the user said before in order to have a true conversation, at least when you build something like a chatbot. That's more or less it. And there's also a nice UI for that, and then, well, this whole thing will work. The tools I have created are quite advanced, so the application I've created is an application where you can talk to a conference content. So this would be JFall 2026. I've ingested the program in a vector database. You then can book sessions for yourself. This is more or less the features I will support, which actually includes all the relevant parts of a serious AI system. Yeah, sure, fine. Okay, so I can say I'm interested in sessions about AI and Spring. And then it even does the whole serve R500. That's great. That's a demo effect. But normally it would work outside of the demo. Okay, so to start with, we need to define some test data. And for this, you could, for instance, rely on Kotlin notebooks. Who has worked with Kotlin notebooks? Some of you. It's definitely worth looking at if you develop in Kotlin. So you just have some code sections you can execute here. And then, for instance, here I can, for my application, define certain users. So I have a first-time attendee for the conference. I have a Java Kotlin developer and a speaker. Those are my different user profiles. and now they are in memory available. The same I can do for scenarios. So I have a first-time attendee. I have a developer who wants to have specific information about the schedule, and so on. And the same for a speaker who wants to maybe similar talks like the ones he talks about. Okay, based on that, I now can also use an LLM, this is what you see here, to create some scenarios. So that's, again, the important part here, use an LLM to do that. And that's what I do here. So I have here your helpful test generator, given the following user profiles, I give them all the users and the scenarios, or a certain scenario, generates 2 prompts for each, and so on. And then it starts generating data I then could use to test my application. You don't have, of course, to do that with a notebook, but as said, the idea is that you play around with data, generate stuff, till you think, okay, these are probably, this covers the most crucial parts of how this application needs to behave. So the scenarios I want to support. All right, and then you need to start evaluating. Well, this is where it's getting probably tricky. How do you do that? How are you evaluating that your application works the way it's supposed to work? You could do it by hand, just enter some prompts and see how it behaves and then try to tweak it. But that's, of course, not something that is viable in the long run. Also, for regression, this won't work. So you need a framework. And well, there we go. There are a lot of open source options. The only problem is that all these options are based on, guess what? What? Which language? Python, exactly. They're all Python-based. TypeScript or Python-based. We're a Kotlin developer, so what you do? Well, there's good news. There is this open source project where I had the honor to add Kotlin support, Docimos. And I think it is a very good project to get into this way of thinking, because these frameworks are very similar to one another. Of course, they all have strengths and weaknesses, have emphasis on different things, but in general, they work all the same way. So if you want to know more about it, this project is definitely interesting to take a look at, and I'm going to show you quite a few examples. Okay, so let's take a look at how you can evaluate whether my application works the way it's supposed to work. So this is Docimos. There's a nice DSL we have created here. We can say we have an experiment. Then you have some data set. You can have multiple of these data sets. And then you have examples. And here I have an example. What's the name of this conference? Very, very basic, right? Start very basic. Then often you have a task. This is where you call kind of the endpoint of your application. That's basically the inference with the LLM. And then here you have a variety of evaluators. And now I have a very simple one, which is the contains evaluator. That's basic, right? Just checks whether the expected string here is contained within my output. And this basically is unit test, right? It's not something mind-blowing. It's unit test that does that. Let's see if it's, apparently it did that. So contains evaluator 1.0. That's the score. That's fine. However, you can imagine that for serious applications, that's probably not something we get very far with contains and regexes, right? That's just not powerful enough. So we need something more advanced. And here comes actually the remedy, which is LLM-as-Judge. Who has heard of LLM-as-Judge? Some of you? Judge is here kind of the keyword. How does this work? Well, you have a test engine. This would be our Docimos framework or any other framework you choose. Then you have your agent on the test. And this is more or less the data that goes back and forth. You have your history, your system prompt, the user prompt, maybe some context. That's what's being sent to the LLM, and the LLM then answers with these system messages. This is the type of message an LLM answers with. What you then do is, with this engine, take all that context and pass it on to a specialized agent that verifies aspects of this conversation. So this is what we do here. We have this LLM-as-Judge, and that's important. Often this should be a powerful LLM. If it's an LLM that is, in terms of capabilities, lower than the one you talk to, that would be crazy, right? That should be at least as smart as the LLM you're using. Otherwise you get a weird judge. It needs to be someone that is capable of judging whether a conversation fulfill certain quality criteria or not. And this is basically what you send along. So you send really everything you send back and forth alongside certain evaluators or expectations, so expected reply, ground truth, quality criteria, tool trace, and so on. All these are sent to these judges. And then they also use the LLM to then score your input. So it's not about true or false, it's about scoring. And you define which score is good enough. And you see here there is a lot of nobody can tell you what a good score is. It's something you have to kind of figure out yourself eventually. That makes it also very fuzzy and kind of hard, but of course, eventually we'll get there. Once you have those scores, then you should ideally also store them in a system for regression. So you want to see that over time, it doesn't deteriorate the score. You want to see that it's within a certain range. All of a sudden, because you made a change, one score drops tremendously. This is actually the kind of important part to realize, oh yeah, I think we have to look at our change and ensure that the score then recovers or adjust the judge. So this is what I have done here in my next test. This would then be a judge, and here we use a very basic judge, and this judge simply looks at the tone. Is the answer helpful, accurate, and professionally worded? That's very basic. Let's see what it does. And you see also here that it uses a judge, and for this particular system, it's simply also Spring AI. Right? It's just, in fact, actually, it's such a client, chat client builder. You feed it, and then off you go. And you see that, yeah, actually my test should fail because I should assert. Assert would be wrong. We see that it actually fails, right? The tone is 0.7, and I expected it to be 0.9. Let's see what happens. So this was the answer was given. Would you like me to tell you about the sessions next? Mighty, okay, that looks like, probably have used a very weird tone. If you're needing a burst to rest, whoa, there's really something wrong with my application. And maybe we can fix this right away. Probably that's something in the system prompt that went wrong. Let's figure that out. Oh yeah, always answering in pirate speech. Yeah, I can imagine, and you don't get a professional wording, right? So you probably need to change that. But this is more or less how it goes, right? Of course, not in such extremes that you have pirate speech, but this is then how you would adjust your interaction. And if I run it now, then I would expect then that my test would succeed. Fingers crossed. Normally this goes quite well. Here you see the whole conversation coming along. And now you see 95%. That's fine, so all green. Okay, so such a judge we've seen now is very basic, right? It just says whether the tone was okay, but it doesn't really say something about data. And there are way more advanced evaluators, and I think what's important here is not how many evaluators there are, but which kind of parts you can evaluate. And these are actually all the parts which have a link to some external system, but it also has a certain probability of performing well or not. So for instance, if we do some vector search lookup, we always have a input question, like I'm interested in Kotlin and AI, which will be vectorized, and it does its vector search magic. So here we also can see whether the context that was returned is relevant for my question. And if not, then probably there's something wrong with our embedding model. We can also verify whether the retrieved items were actually relevant by themselves, or the other way around, whether the relevant items were actually retrieved. So on this axis we also can do stuff. Then what we also can do is basically see whether the context we provide in our prompt was accurately used by the LLM. So was the output grounded in the context? Or a hallucination evaluator, did the output contain information we didn't provide? Then it hallucinated. Right? These are actually the aspects I can zoom in and then test. When it comes to tool calls, I can verify whether a certain tool was called I expected to be called or not. So let's see this in action, because it's not that hard, at least to see it like that. So here we have, should retrieve general venue information. So I have some tools that give you some general information about where it takes place, how much it costs, and so on. So these would be my examples. What's the address, on which date, very basic and simple. What is the regular price? Then here I figure out, first of all, I do this call to my API, and then I have some tool recorder, which just record all the tools that were called beneath. Spring AI has some nice utilities to do that. And then here I have a variety of more advanced evaluator. I have here the tool call evaluator, I created myself because it wasn't there yet. Then we have the faithfulness evaluator, which you've seen, and contextual relevance. Then we also have a reporting, and we'll see in a minute what this does. Let's execute it, and then it's also interesting to see more or less how far it goes, for instance, to see whether something is contextual relevant or not. Just that you get an idea, right? Not in great detail, but an idea how this is going to work. So for instance here, this is the context we have provided, right? So this is the prompt that goes to the judge, literally a prompt, saying, okay, I want to have a result as a JSON string. This is the context that was provided. And given that context, these are the facts it retrieved out of the context. And then it did a verdict of every single part, whether a certain effect that was provided is correct or not. So you have here a very granular way of doing those verdicts. Okay, on that level, it tests whether an example was grounded in truth or not. And then it will give a score based on how many verdicts were yes or not. And there are others that do this, again, in another way. So these are the ones you would use off the shelf, but of course, nothing prevents from creating your own judge. And we'll talk about that in a minute. So let's see whether it succeeded or not. Yeah, so all these evaluators, because they're very basic questions, they fulfilled actually their task good enough. Okay, so this was very granular, but sometimes you also want to see how a whole conversation would take place. How does the system react when I have a whole conversation going on? Yeah. And for this, you could rely on something like a conversational application, which simulates basically a user. So we have a user who wants to complete conference schedule with preferred sessions. That's what the user tries to achieve. Then we have here a certain persona. This is a type of developer. These are kind of his interests. And now we see, given this goal, can our application fulfill the need to kind of fill up the schedule with sessions matching those preferences? That's not a one-off example, that's really kind of a whole interaction taking place. And then at the end, we want to know whether the user was satisfied, was the goal completed, how was the tone, helpfulness, and there are, well, many more you could think of. How the quality of this conversation took place. Let's see that in action. Then ideally we should see a whole schedule being completed. So now it will just do its whole ping pong. Here it does, for instance, queries about certain sessions. So there were some lookups being done with our tooling layer. Now it starts filling up. You see certain sessions already being filled. And then hopefully eventually you also can say how many turns the judge conversation takes place. It should be filled. See already now the schedule is filling up. So from 11:30 till 18:45 we have actually the whole schedule filled for this particular person. And then again, this is something you also have to maybe verify with an eye if this is more or less correct. But this gives you actually a nice way of simulating whole conversation, see how the system maybe all of a sudden drifts or just keeps, performing well or not. So this is it, our simulator. Then you have the trajectory, and then literally the whole trajectory will be given to the LLM. So it's not a one by one, it really will collect the whole conversation, pass to the LLM, and then with the goals we defined, verify whether this whole text actually satisfies these or not, or to what degree they're satisfied. Then you also get a scored eval. And at least in Documos, you also have then a kind of website like the one here, where you then see what just happened and what kind of scores you had depending on what just happened. So this is a tool already provided to kind of persist the interactions you had over time. Of course, you can create your own tool, but it's just there and it's kind of fun to have that available. Okay, so are we there yet? First of all, plug and play. Some evaluators are probably not good enough for you. So if you build serious systems, then probably you need also to tweak your judge. The way this goes, you probably take a judge off the shelf. You will also score output manually yourself and then see whether the judge scores them the same way. That's very important. So there's also manual labor involved in that. So it cannot be fully automated. You also need to verify whether your judge does it good enough. And if you have some variations there, then of course you need to adjust the judge. And of course this is again a iterative cycle where the judge is refined over and over again. So by now we have identified our goals, we have built our harness. That's a very interesting one, security. A hacker used AI to automate an unprecedented cybercrime spree, Anthropic says. So it used chatbots of 17 companies to commit serious crimes. So you better make sure that also your chatbot you're offering is kind of not open to these kind of intentions. For this you have actually red teaming. That's not part of this project. The only thing I would like to show you is that when it comes to vulnerability of LLMs, bear with me, the list is just insane long. So these are types of LLM vulnerabilities. So let's see how far this goes. So here they start, types. These are all vulnerabilities. We still have vulnerabilities. Still going. We're still halfway. We go on. There's still all vulnerabilities. There we go. So that's why also right now I believe that the latest model they will release at Anthropic, the big companies try to test that model because it's going to be so important. Everybody's going to use it. They want it before being released to kind of reduce those kind of abuses as much as possible. Because there's so many loopholes to kind of bring your application down. Be aware of that. Okay, so considering the time, let's move on. So then you're live. And once you're live, well, I think we can lean back and enjoy. In the story that also doesn't go well, this was what he did, and then things got really, really wrong. And this is literally the kind of role you'll get. We will all get babysitters. Once an application is live, more than ever, you really need to babysit it and very, very attentively figure out whether the thing still behaves the way it's supposed to behave. So what we first need is extensive logging. So everything that's happened with an application should be logged. And for this you can use Langfuse. That's what I have here. You get an idea. Langfuse is kind of standard in Spring. You just can more or less turn it on. So here, everything that has happened is kind of nicely logged. So here you see actually the input, you see the output, you see what other calls were made. You can even see tool calls that have been performed. So let's take another one. And so on and so on. So it is in a very detailed fashion. Even the select statements that were done in our vector database. So on the most granular level, everything is traced. And that is important for various reasons. So first, request replies, that's kind of evident, but also tokens and latency. Tool calls, maybe there's way too many tool calls, and errors. Things can also really plainly go wrong. Like I didn't find data. I've seen tests where it said, yeah, it's professionally worded, everything is okay, but it said I didn't find data. But it looked okay, but it was not, because there was just an application error. Well, are we missing something? Anybody an idea? Is this enough to really make a cutting-edge bot? Security? Yeah, let's assume we've done some red teaming here. Yeah, that's also something you will have to build in, and is actually generally built in, user feedback. That's why you have to sum up, sum down. That's super important for those companies. With this data, sum up, sum down, they tweak and tune their LLMs. So feedback is absolutely crucial. Because when something is in production, you can also monitor certain things like you monitor in traditional systems. The ones you see here, errors, tokens, latency, that's fine. But what you also need to do is frequent inspection of just some traces. Randomly pick them and look at them as a human and then grade them, whether this was okay or not. And this also applies, of course, to inspect the feedback. So in my application, I got a 500, so unfortunately it doesn't work. But also here, you see that I have built in a sum up or a sum down. And then here you see that, well, someone has sent some feedback. You get the input, you get the output. Here it says, my apologies, matey, I meant no offense, and I don't like your tone. That was what user said. Okay, apparently this pirate thing is not good for us. And that, based on that, you can also, again, adjust your application. And ideally, you will also actually take those data and fuel it back into your test harness to then improve your test base based on production data. So production data will be a very important source of ensuring that your agent is getting better and better over time. So tuning your agent is really a crucial part of the whole development of these kind of applications. Okay. And with that, I think we are already quite far. As said, this is what you do. You would turn these bad rated traces into failing test evals and then fix the application. A bit like test-driven. Often when you have an error in production, you would first write a test that kind of mimics that error, and then you would fix it. And as such, you already upgrade your test harness. Same rules applies here. And as such, you automatically will extend your regression tests. You might also calibrate your judges, because your judges say, okay, I'm fine, but maybe the judge didn't do a good job. So you need to kind of tweak and tune that. And ideally also identify reasons of systematic failures, where you see, okay, this is kind of a line, I see various errors happening in this area, and then maybe improve a system prompt or a vector lookup, whatever. And that's the art then to make that happen. Yeah. So this is more or less it. When you're in production, then evals is something that is part of your job. Babysit that application, and this will actually fuel your harness up to a point where probably you get quite a decent and stable system, where you have to maybe look less at those traces. And by doing so, hopefully, we will be capable of controlling the superpowers that was given to you. Thank you.
Thanks, Urs. Let's have some questions. Anyone? Yeah.
The answer is probably going to be it depends. But I was wondering, before you go live, you need to have some kind of baseline on what you want to test. There's a lot of vulnerabilities that you could test. How do you determine what you need to test before going live? How do you determine when you're just good enough before you go live? And what your score should be before you trust it enough to go live?
Yeah, I think indeed that's a very good question, and it depends. I don't know if this is needed to tell here. At least the way I've seen it so far is that it's very similar to security testing of traditional deterministic systems. Often you also don't have a full security test for every minor release, right? You often have some penetration tests once in a while. If you have some major new features implemented, then you would do the red teaming tests, maybe hire a consultancy company to do that. Whereas if you have some minor change, you probably just would rely on your official test harness. So I think the same rules apply here. Why? Because these kind of tests are quite costly, right? There's a lot of LLM interaction going on. Often you also will use a decent LLM. So every test run just costs you money. And especially if you would do all the security vulnerabilities, that's just not affordable. So finding the right balance here is just crucial. And probably in the beginnings you would invest more heavily into this red team testing, but over time when you have some confidence that not major things have happened, you babysitted it well, this is how kind of you build up the trust. Yeah.
There are some known biases when using LLM as a judge, right? that LLMs tend to evaluate better the responses that are generated by LLMs that are from its own family, also longer responses.
Yeah.
Did you address this during the fine-tuning of your judges? Do you maybe do some average between different models?
Yeah, so as said, there are also strategies there. First of all, ideally use a different LLM and a more powerful one, if that is possible. That already helps a great deal. And what's also important is that you do human labeling. So human labeling is a crucial part of the process. It's labor intensive, but it pays off, because if you then have labeled answers where a judge just is perceiving it differently, there you probably see a weakness of a judge. The bottom line is still that you kind of treat something probabilistic with another probabilistic solution, right? So it's really far from perfect, but it's better than doing nothing. So it's the least bad option we have. But indeed, it's not perfect. Yeah.
Okay, thanks.
If the judge is more powerful, why shouldn't I use that LLM for the main task, which is what it's all about?
That's a very good question. It depends how deep your wallet is, right? Bigger models are considerably more expensive than cheaper models, and depending on what you have to do, for instance, summarizing stuff on a website, I think also less powerful LLMs can do a decent job there. But if it's really about making decisions on a business workflow, you probably want a better one. So that really depends on the application you're building. And I think you always strive, bye guys, you strive and opt for an LLM that is good enough and maybe just a bit more than that, to also have the balance between performance and cost. Yeah.
The feedback of the customer, is it also included with the prompt and the response of the LLM? And is it ethically allowed to use those?
Yeah, I guess all traces you collect in a company is allowed. GDPR will apply, so eventually you need to clean stuff up. You cannot keep it forever, but this is how companies are doing it.
It's fully traceable to the prompt, original prompt of the
Yeah.
user and the
Yeah. So yeah, indeed, the question is, do you want to send it to Langfuse if it's really crucial data that is being sent back and forth, because it would be a third-party system where this data is probably need to, but you also can host your own instance. But yeah, you have to treat it actually like any other logging or audit data that is being used. Yeah. And I have, for instance, here I have a feedback eval test, which basically accesses my Langfuse account and then also performs these tests to see whether it passes a judge. So this is also something you eventually will automate to a certain degree. Yeah.
Hi. Have you ever considered making a system that adjusts itself? So the judge changes all the prompts within the system and then judges that again and it goes looking, improving itself?
Yeah, that's an interesting approach. I have not tested that. But that's... Yeah.
The interesting thing is that when you do, for instance, not only the confidence scores, but also the rationale, see what they do, and you can also again judge that thing that has been made instead of that. Yeah, sort of. You can just easily that pretty much.
Yeah, that's the critique way of prompting, right? Self-critique is called. So you actually say, okay, produce an output LLM, and then criticize your output yourself. And so that's actually an existing pattern that definitely could help to improve an LLM judge, this kind of technique. Yeah. And that makes it also kind of hard. There are so many possibilities and techniques to apply. So I think the best advice would be start simple before making it very complex with a lot of scores. Just start simple and then from there expand to what's really needed. Yeah. Cool.
Any other questions?
Cool. And last but not least, they are stickers. I got from JetBrains, so because you came here. Yeah. Okay, sorry about that. Yeah, sure.
So, you talked about the reality testing. talked about red team testing. If a red team testing gives any findings, I guess you could then recreate such a scenario and then put it in a test. So is that something you would do, or how would you approach that?
Yeah, I think so. Really, I think you will have to treat this like regression. So you want to be sure that these findings are covered by ensuring that also over time it will be covered. And not if you change your LLM version, which of course can happen, that all of a sudden such vulnerability would all of a sudden arise. Even so, probably if you switch an LLM version, you probably also want to do another red team test because you really don't know how it behaves. So, yeah.
Right. And then a very non-technical question. You started with some stats from research that was done. How much value do you put into that? And do you take this into account in decisions that you make in your experimentation? Like 90% of AI experiments will probably not make it to the end of the year, for example. And I feel like the development of AI is going so fast that I basically expect that as soon as some academic research result comes out, it's already behind the practice. Because just seeing how good Claude Code got in the last half year, any research outcome before that, I think I tend to ignore.
Yeah, so I think I definitely would not ignore it. The bottom line is quite simple. If you build these applications and you don't start building such an evil harness, eventually you'll be out of business. Because if something goes wrong, you have really no clue what went wrong, you have no way to deal with it, you have no safeguards at all. So eventually you can very quickly be out of business in a serious way, because you might have a serious breach. However, if you start with such an evil harness right away from scratch and then incrementally build it up, the chance that you're in business or that something happens to your application that gets a business breach is much, much lower than if you just believe the model will get better and so on. So I think the message here is, if you build these applications and you take it serious and it's a crucial part of, so the LLM is a crucial part of your application, then you better start with the harness right away. And then at least that's why also OpenAI and all these companies are still in business, because they guardrail this whole thing. And quite a big investment of their time goes into that part. So do that too.
Great takeaway, I think. Thank you.
Cool. Thanks a lot. Yeah.